Okay, okay. Yeah. So identifiers. So what are the identifiers? What does it mean? So identifiers means just technically in Python the names which we are using in coding. So let's say I'm writing one code. Okay, I'm writing one code. So here what I'm taking the names. So first underscore name equals to Yogi and some a equals to 100. So this first underscore name is a variable. Okay, so this is a variable and a is also a variable. So you can take any name, right? This left side, the variable names so different developers will take their own names. So that name which we are taking, which we are creating the name in Python coding. Okay, so that is the identifier, the name which we are using in the code. So that those are the identifiers, but there are some certain rules we need to follow while taking this identifiers. Okay, so for example, demo1.py. So this is a file name and variable name. Okay, variable name, some functions in Python. We have functions concept, functions name, class name. So there are different names. Okay, there are different names. We will take different names. We will take um, in the coding. Those names technically we are calling as identifier. Those names we are technically calling as identifier. So are you clear this? What is identifier now? The definition? Okay. Yeah. So it can be class name, function name, or module name. Module name means like file name. So for the coding, we are giving and saving one name, right? So that file name is called module name. That file is called module. Or variables means like example, a equals to 100, b equals to 200. So a, b, c are the variables. So these all are names. So instead of calling names in Python, technically we are calling as identifier, but while taking that names we should follow some rules. Okay, so the identifier should allow the alphabets, lower case and uppercase, and also it will allow the digits. Okay, and also it will allow the underscore. So example, value underscore 1 equals to 10. If you take another example, first underscore name equals to some data, Yogi. So this is also valid identifier. And second rule is, you should not take starting with the digit. Okay, so you it is wrong. So if you see one value equals to 10, so this name we are taking starting with the digit. So you should not take like this. You should not take like this. Okay, so for example, here I am taking one value equals to 100. Okay, I'm just saving, I'm trying to run this. See, invalid decimal literal. So this is telling the syntax error. See, this should not take in the starting. So that is the invalid identifier. Okay, and the third rule is, identifiers are case sensitive. So uh, for example, here you are going to print first underscore name. Okay, first underscore name. So this first underscore name you have taken Yogi, and you are printing this first underscore name. Let's see the output. So it is printing the Yogi. And now if you take first underscore name like this. Okay, so this is first underscore name. Here you are taking capital F, first underscore name. So both are first underscore name only. But when you run this module, it will throw an error, not name error. First underscore name is not defined. So did you mean first underscore name? Yes. So here it is capital, here it is small, because Python is case sensitive. So you must to take the same this thing only, same same identifier we should take. So both are not same. It is a case sensitive. And fourth rule is we cannot use the reserved words as identifier. So reserved words means already when Python is developing, some names already taken. So, for example, this guy Guido van Rossum, okay, who developed Python. So Guido van Rossum. So when he was developing Python, when he was developing Python, he used some words, some names he was already taken. We should not take them as we should not take them as identifier now. So for example, so to create a function, generally there are concept functions classes in Python. Okay, so for example, I'm giving you create a function. So to create a function, we will use this keyword def space some function name. Okay, function name, and open and close parentheses and colon, and we will do some logic here inside this. So this is the function. This concept is called function. So we will learn it later, but likewise we will create a function. So in this function, this def is there, no, def. So this is already used to create as functions. Okay, so this you should not take as a identifier. This is a reserved word. So for example, you should not take def is equal to 100, like that. You don't take. Okay, and for example, to create a class, so there is a class keyword or reserved word. So class name, like that we will do something like this. There is a class concept in Python, so we will see it later, but so likewise we will construct a class. Okay, so this class key name is already taken. So you should not take class equals to some hundred or thousand, like that. Okay, you don't take like this. These words you should not take. So that is the meaning of this. We can't use the reserved words as identifier. Okay, so print equals to def equals to, for example, so there are if else conditions in Python. Okay, there are if else conditions in Python. Okay, so you should not take if is equal to 10, else is equal to 20, like that. We do not take, because if and else already used. These are reserved words, so we should not take them. Okay, I hope you got it, this reserved word. Yeah, anyway, we have the reserved word topic in the next after this identifier. So there we can see what are the available reserved words. Okay, so these are reserved words we should not take as a identifier. And there are no length for identifier. There are no length for identifier. Okay, there are no length for identifier. Let me remove this. Okay, yeah, so there are no length for identifier, but not recommended to use lengthy identifier. See, for example, so here I taken first name equals to Yogi, and I am printing the first name. Okay, for example, I'll take a variable like this. Okay, so some 100. So is this a valid identifier? So, yeah, it is a valid identifier. No, no, it is valid only. So if you print this 100 will print. Let's see. Let's run this and print. So here you can see 100 is printed. This is valid identifier only, but it is lengthy. It is very lengthy. So what what we are recommending is that there are no length for identifier. You can take how much you long you can take, but not recommended to use lengthy identifier. So take the short identifiers. So this is it is valid, it is correct, but not recommended to take this much length. Okay, so that is the hmm. And dollar is not allowed in the identifier. Dollars or spaces will not allow in the identifiers actually. So cash equals to 100 is correct, but ca dollar s dollar h equals to 100. So these special symbols will not allow. Only here already we mentioned this allowed characters, only this. Other than this it will not allowed to take the name in Python. Alphabets, digits, and underscore only. No other spaces, no other symbols we should not take. So these are the rules we need to follow when we are writing the code, when we are taking the names for coding. So you got this concept? Any doubts? Okay, so then which of the following are valid Python identifiers? So we can see here. Uh, so you can tell me. So one, two, three total is this valid identifier? No, because we should not start with the digit. And total one, two, three is a valid. And Java to share. No, no. Case sensitive means if we take the name in the next after defining this name, if you want to use the same variable, same name, you can take same exactly, don't use a uppercase something. So then that is hmm. So it is allowing alphabets and digit, so it is valid only, it is valid only. This one, ca, not valid. Dollar, hmm. Yeah, this one, no, it is valid because we told underscore is allowed and alphabets is allowed and digits is allowed. So, but we should, yeah, it is allowed. But there is a meaning if we keep it in the starting. So that variable is a private, like everyone cannot see that data with this. So we'll see that thing in future classes, but it is valid only. And def equals to 100. Def not valid because def is a reserved word. So that, yeah, so reserved are, we can say, keywords both. So let's see the Python keywords or reserved words. The next topic is reserved words. So reserved words are nothing but set of keywords in that are reserved, that cannot be used as a variable names, function names, class names, or any other identifiers. Okay, so simply keywords are the reserved words that are already used while developing the Python. Okay, so these words we cannot use anymore for any other identifiers. So we will use the each keyword has their own purpose. Okay, so false is a boolean, none is a none type, like, so when we want to define the null values like empty values, then we will use the none. So false, true, these are the Boolean values. If you want to define some Boolean kind of data, we will use them. So every keyword has their own purpose. So we will use all of these in the coding. So at that time you will know what is the use of these keywords. So right now these are the keywords: false, none, true, and, as, assert, async, await, break, class, continue, def, del, elif, else, except, finally, for, from, global, if, import, in, is, lambda, non-local, not, or, pass, raise, return, try, while, with, yield. So these are all are keywords. So these keywords we don't use for identifier. You don't take like non-local equals to some place name, something like that. You don't take lambda equals to some 100, 1000. You don't take these keywords as identifier. Okay. So, to remember, there is one observation from these keywords. All reserved words are in Python contains only alphabets. There are no other digits, no underscores. If you see, if you observe this from these keywords, so these are almost 30 or 31 keywords are there. Okay, and all are alphabets only. No underscore, no capital. Okay, all are alphabet only except three keywords: false, none, true. So these are title case, like first letter is capital, boolean, true, false, and none type. So only these three keywords are title case. Title case means first letter in a word is capital. Okay. So if you want to see these keywords, we need to print this two lines. If we need to write these two lines, I'll show you here. So basically the imports we will do in the top, but there is a topic imports modules. At that time we will know. See, here we use this import keyword. So this import keyword is, we will see that is what is the use of this import. We'll see in the future class. So there is a concept, imports, module imports. So that means like from another module to one module to another module, we will import some code from one file to another file. So for example, there is a file keyword. Okay. So print keyword dot kw list, print of keyword dot kw list. So run this, save. Now you can see. So these are the keywords it is showing: false, none, true. Okay. So these are the keywords. Okay. So definitely you will you will use these all keywords. So at the time, one by one you will remember. So not need to like remember right now, but when we are going through the classes, no, so at the time, so one by one we will use them, and then you will remember those keywords. Okay. So now variables and unpacking. So what is variable and what is unpacking? Okay. So variables are containers for storing data values. Variables are containers that storing the data values. Variables x, here x equals to 5, y equals to some John. Okay. So here x and y are the variables. So these are the containers. These are containers for storing data values. Okay, so this phi is storing x in x. So John is storing in y. Right. Okay. So Python print function is often to use output variables. So we already used this function print, but here we are telling what a print function will does. So the Python print function is often used to output variables. So to see the output variables. Okay. So to display the output variables, we will use the print function. Print function. Okay, so these are the variables x and y. Okay, so variables are nothing but containers for storing the data values, for storing the data values. Okay, and what is unpacking? Unpacking means multiple values can assign into multiple variables in one line. Okay, for example 1 comma 2 comma 3, so these multiple values we are assigning into multiple variables, into one multiple variables a b c. 2 is equals 3, yes. So this is unpacking. So if you give it like I'll show you in the example. So here you can see a equals to 10, b equals to 20, c equals to 30, d equals to 40. Okay, so rather than giving like this, okay, print of a, print of b, print of c, print of d. Okay, so rather than giving like this, okay, let me run this. Okay, 10, 20, 30, 40, it is printed. So print function is often to use display the output variables. Okay, this is printed. Okay, so basically, so for this line of code, it is printing the data here. Okay, so when we run this program, so it will execute from top to bottom, line by line, this line, this line, this line, this line, this line, this line, and this is also executed, this is executed, this is executed, this is executed. Okay, so what will happen for these things are executed. So these things are executed, then it will store the data. 10 will store in the a container, b container, c container. So there are some containers like this. So this is for a. Okay, so this is for b, like a memory storage. C for some memory. So for every variable, every line of this execution, one memory is allocated. One memory is allocated to that data. That data. So this is 10, this is 20, and this is 30, like that. Okay. So likewise, it will execute one by one line, and wherever you use the print, there it will print the output. There it will print the output. Okay, and yeah, so unpacking, so here we are doing like this. So instead of doing like this, you can do like p comma q comma r comma s. I'm taking different variables. Okay, so equals to, you can use 100 comma 200 comma 300 comma 400. So in one line it is completed, right? So taking multiple lines, so in line, so what will happen? 100 is assigned to p, 200 is assigned to q, 300 is assigned to r, 400 is assigned to s. So like this it will assign. Yeah, can you go on mute? Somebody join, or else Okay, just a minute. Okay. Next. So this is unpacking. Unpacking means so number of variables and number of values will be assigned to each variable. Okay. So now if we write print of p, okay, and print of q. So like this. Or else if you can print like this, it will print in same line. Okay. So let me run this. Now you can see. So what will happen if right side, if right side is remove one value, so left side we have four variables, okay, and right side we have three values. So what will happen? Mhm. No. Actually, what will happen? It will throw an error. So because it is expecting four, but we given only three. So whenever it is matching, then only it will not throw an error. So otherwise it will throw an error. Let me run it and show you. Yeah. So here the beauty of Python is here it is it will give you the error description in detail, like so expected 3 got 3, expected 4 got 3. So that means this is expecting 4, but it got only 3. So it is mentioning the line number, okay, line number 20, and the line, which line it is causing the issue, and what is the error name, and what is the description. Not enough values to unpack. So there are no enough values to unpacking. So that's what here it is. Okay, so let's say for example I'm giving four values, but it is expecting only three. I'm giving four values. Then also it will throw an error. Let's see the error this time. See, values too many values to unpack. Expected three only. So we gave the too many values, but it is expecting only three. So that means we are giving more than three, but it is expecting only three. So we gave the too many values. So this is the error description it is giving to understand us. Okay, so this is the unpacking. This is the unpacking. So now it will not throw an error. So it is giving. Okay, nothing. If you want you can do like this also, but like if you want to write it in, if you want to reduce the number of lines of code, we will take like this unpacking. Okay, so next, so we covered identifiers and reserved words, and next we'll see the data types in Python. Data types. So what are the data types? So data types don't store the value of data. That is the representation of the data. Okay. So for example, a equals to 100. Okay. So 100 is the data, but what is data type? Data is different and data type is different. So data is the this value, and data type is what type of this data. So this is representing the integer. Okay, so 12.4, this data is representing this data is representing float value. Okay, just a minute, okay, so data type means the data we are what type of data it is, that is the representation. Okay, so data types don't store the value of data, and they represent only the type of data that is stored. Okay, type of data that is stored. And in Python we are not required to specify type explicitly. So based on the value provided, the type will assign automatically. So hence Python is dynamically typed language. See, in other programming languages, let's take this one, C language. Okay, in C language, how to take the variables. So if you want to take a is equal to 10, you should take like this: int a equals to int a equals to 10. Okay, so as a programmer in C language, we need to specify the data type. Okay, so I'm declaring a is equals to 10. This a is int. Okay, for example, I wanted to take a string str, some s is equal to some yogi. Okay, okay, so this is string. So we need to, as a programmer, we need to define the data, what type of data it is. We need to define the data type. But in our program, in our Python, we need not to specify the data. So here you can take directly a equals to 10, b equals to 20, like for example, f is equal to 10.5. So automatically, from s is equal to some yogi, like this. So automatically, based on the value provided, the Python will understand what type of data it is. We don't need to specify the data type. Okay, see, it will be assigned automatically. See, based on the value provided, the type will be assigned automatically. Hence Python is dynamically typed language. We don't need to specify what type of data it is. That will understand. And every data type in Python language is internally implemented as a class. Okay, so right now we don't know what is class. Okay, but in advanced topic we will learn what is class and how to construct a class. So what are there inside a class, we will learn. But right now, just remember, every data type is a one class. Okay, so for now I'm going to tell how to create a class. So to create a class, we will use a class. Okay, keyword. Okay, class keyword, and some class name. Okay, let's say take a and colon, and here we will write some logic inside this class. Okay, so this is the structure of the class. Okay, right now you don't know class, that's why I am giving this syntax, how it will be the class. So what it is saying here it is saying every data type in Python language internally implemented as a class. So it is internally one class for every data type. So for example, let's say data type is, this is integer, right? Int. So this data type is int. So according to this statement, every data type in Python language internally implemented as a class. So according to this statement, for int data type, there is a class called class class int int and colon some logic. So remember like this. So every data type there is a class int, okay, class float, okay. So for every data type there is a float class int and class float, okay. So that is the meaning of this statement. Every data type internally implemented as a class. Okay. So whatever the data types here, see int, float, complex, boolean, and string. So these all are classes. Here also there are some more data types: list data type, tuple data type, and set data type, and dictionary. Okay. So these all are classes: class int, class float, class complex, class bool, class str, class list, class tuple, class set, class dict. So these are our classes, because here it is mentioned every data type is internally it is a class. Okay. So data types are categorized into different ways. One is a fundamental data type and another one is a collection data type. One is the fundamental data type and another one is the collection data types. So fundamental data types represented classes or objects. Okay, this data type classes or objects are storing in only one value. Okay, see here these a equals 100 is only one value, 12.4 is only one value, yogi is only one value. So one value is storing. So those kind of data types are called fundamental data types, like int, float, complex, boolean, string. Okay, so these all are fundamental data types. Okay, these all are storing only one value. These all are storing only one value. Okay, these all are storing only one value. So for example for int. Okay, so let me take new file. Okay, rather than taking here, so let me take a new file. Save. I'm going to take new file and file, save as I'm going to take the file name is data types.py and saving. So already it is there now. Okay, data types 1.py. Okay, so this is created new file. I'm just closing the previous one. Yeah, so I took the new file. I'm going to write a program for this. So a equals to 100. Okay, now this a equals to 100 is what data type it is? It is a int data type, right? It is a int data type. So and one more other type of data types are collection data types. So these are storing the group of elements. Okay, so fundamental data types will store only one value, but collection data types will store the multiple values in a single variable. Okay, so here see the difference: a equals to 100, here a equals to 1 comma 2 comma 3, likewise. So we are storing multiple values in this data types. So what are those collection data types? List data type, tuple, and set, and dictionaries. Okay, so Python contains several inbuilt functions. Like we already used print function, right? So here we used print function. So this print function is a inbuilt function. So that is used for output the variables to see the output. So likewise, there are some other inbuilt functions. Inbuilt functions. So one is the Python type function. So function is often to use to check the type of variable. So as I asked the question here, So a is equal to 100. So what is the data type of this a? Okay, I don't know. Like, then how to check? How to check? So there is a inbuilt function, type of a, type of a. So this type function will tell, this type function will tell us so what type of data it is. So if you want to check, if you want to print, so this type of a, type of a I am going to print. Okay, so then if you run this, it will show you the class int. It will show you the class int. So as I said, every data type is internally implemented as class, and also here it is also telling this data type is class int. The name class name is int class. So what data type it is? Int class. Okay, class int. There is another function, built-in function, id. So python id function. So this is oftenly used to check the address of the object. Okay, and let's see what is the address, what is id function, will tell you. And another function is input function. So function reads in the string form. So the function, it will take the user input. Actually, this is often to use, this input function is often to use, take the user input and it reads in the form, in the string data type. Okay, so I will see this input function also, how it will. Okay, so type is what it is showing. It will tell us what data type that is, that variable. And id function is used to check the address of the object. See, as I mentioned, for every line it will execute, right? So and it will give you the output. First line it will execute, second it is print statement. So this is executed, and it is printed output here. Okay, and what happened when this is executed? So as I told, a is a container, the one memory is allocated, and that 100 is stored here. I told, right? Just a minute. Right, so here uh, a equals to 100 means, when this statement is executed, so memory is allocated for this data. Okay, so this is called, this memory allocation is called basically object. Okay, so this memory allocation is basically called object. What object it is? So this is the data is stored integer, right? So we can say this is the int object. This is the int object. Okay, this is the int object. And for this address, for this memory, there is some address like some 2 4 5 6, something like that. So there is some number. So that is the address of this memory. Okay, and what is the container? A is the container or variable. Okay, so in this is holding this address. This is holding this address. So basically what happened, when this line is executed, a equals to 100 is executed, what will happen? Internally, memory was allocated for this data, and that data is what type of data it is? Integer, right? So then int object is created, int class object is created, and for every object there is one address. Okay, if you want to see this address, if you want to know the address of this object, then we will use the int, sorry, id function. So to print that id of a, okay, now run this. Okay, now you can see this ID is 43533724448. So in this address it is stored. Okay, and basically all are thinking like when a equals to 100, the 100 is stored in a, but actually it is not like that. In a address is referring. Okay, if you ask the value of a, hey a, can you give me your value, then it will not give us the value. It will tell us the id. It will tell us the id. So whatever you are looking the data, that is there in this address, you can go and refer this address. So that will the mechanism here. So actually this a will not store the value. Okay, actually the a will referring the or pointing the address. If we ask the value to the a will give us the address, not the value. Okay, so based on the address we will print the data. Okay, are you clear? Any doubt in this? Okay, now, so this is the id function and input function. Sorry. Yeah, an input function is used to take the user input. For example, here what I'm doing, if you observe what I'm doing, okay, so I'm taking some p equals to 100. Okay, q equals to 200. Okay, and I'm doing print of p plus q, p plus q. Okay, and I'm saving. What is the output of this line? What is the output of this line? P plus q?
100 200.
No, no, these are integers only, right? These are integers only. So it will be the 300. It will be the 300. Okay, now I wanted to the sum of different values. Now what I have to do, I have to go and check the change the values here, 200 and 300. Again I need to run, and here 500 again. If I want to check for other values, okay, other values, I need to change the code, right? Every time I need to change the code, and I have to check the output. So if we use if we use if we use if we use input function. Okay, for example, p equals to input. Okay, and q equals to input. Okay, and if you print okay, sum equals to, okay, sum equals to sum comma p plus q. Okay, p plus q. So sum equals to this string is, I am statically given this in print. It will print as it is, and after comma here p plus q, this will be dynamic. So based on the value, so here I am not giving the value, I am asking the value in from the user. So where I executed this run. Okay, so after completing this p plus q, 200 plus 300, it is 500. Then here the cursor is blinking, right? Then here cursor is blinking. So I am giving 100 and 200. Wait, let me run it again. Sorry. Run this module. Okay, so here it is blinking. Okay, it is asking the 100, I give second number is 200. Okay, so now it is giving sum equals to 100, 200, because it is doing concatenation. If we use the input function, if we use the input function, it is taking in the form of string, as I mentioned here. Like it reads data in the form of string, even it is integer you are entering, but it is taking as a string. It is taking as a string. Just a minute. Okay, so it is reading as a string. So that's why the strings, if you give the strings, it will take the concatenation. Okay, so let me give here, like instead of 200, if you see some a, some a, and if you give here b equals to, okay, q equals to, okay, then p plus q means, so let's see the output. So it is yeah, so it is concatenation. Same way here, when it is taking the input from the user, it is reading as a string. So that's what here 100, 200 is giving the 100, 200, the concatenation. It is in the string format. Okay. Then how we will take it as int? And how we will take it as int? Okay, and also we are not knowing, this cursor is blinking, but what should we do? We are not knowing, right? So that's what we can do. In input function we will give the user friendly message. Okay, like in string, enter a positive number. Okay, enter a number one. Okay, or enter a, enter first number colon, and here also you can give enter second number. Okay, so then here it will show in the input. So see, after printing yogi, so it is enter first number 100 and second number 200. The output is sum equals to 100, 200, because it is in the form of string only. But how do we take it as integer? So here we are telling number only. We are giving number only, but it is taking string. So how can we handle this? So that's what we have the another concept called type conversions. Okay, type conversions. I'll give you one example. Okay, one example. So then you can try to convert other for other data types. So let me give you one thing. So what is typecasting or type conversion? What is typecasting or type conversion? So that means converting the data type from one data type to another data type, converting data type. So because here, why we need to convert? Because here we are giving integer only, but that is taking in string, but we need to convert it into string to integer, right? So that's what we have to do conversion. Okay, so how to do the conversion? So here I am writing print um, type conversions. Okay, type conversions. Okay, so if you give like this, no, so it will print same thing. It will print same thing. Okay, so now what I'm doing, I'm taking one example, a equals to 100. So this is int. So what you can do, you can print converting into to float. Okay, float float of a, and print into to boolean of a. Okay, print. So what are other types here? I mentioned, right? What are the other types? Integer, float, complex. So do you know what is the complex value? How it will be? So complex is, first of all, let me take the all the inputs. Okay, so inputs I'll take a equals to 100, b equals to 10.5, sorry, 10.5, c equals to string, and d equals to some 4 plus 5j. This is the complex number. Okay, e equals to capital T or UE, or true or false, you can take false. So both are boolean only. Okay, so these are the data type: int, float, string, complex, boolean. Okay, into float, complex, boolean, string. Okay, so these data types we can convert it into other data types. So for example, here i'm taking a equals to 100, right? So this 100 we are going to change into float. Okay, and 10.5 we are going to change. First let's complete, from into to other data type, into to float, into to boolean, and into to, sorry, string. Okay, and print uh, complex, complex. So into to float, boolean, string, complex. Okay, after that, you can take the b value from float to int. You can convert into string, and complex, and boolean. So here it is already complete. You got this conversion. Just you need to use that data type and of the data which you need to convert. So in this it will cover, like whenever you are taking this input, no, so this is in string. This string to you will convert it into int. So how you can convert, so the same thing I'll take it here. So here I'm converting integer. So int of this. Okay, and here also int of this. So now it will convert, as soon as we receive the string, it will convert into int. Then that time it will give you the summation of the integers. Okay, so let's run this program. See, first number I'm giving 100, second number I'm giving 200. Now this time 100 200. Okay, sum equals 100 to 100. So after type conversions, so here it is asking now, enter first number 100 and 200. This time it is giving sum equals to 300. So here before converting, and this is after converting from string to integer. So here this is string. Okay, and we are converting into integer. Okay. So likewise what you can do, you can, here I already given one data, right? So you can convert into other data types, float to into float to, complex float to boolean, like that. And to convert the boolean you have to use like this bool of some data. Okay, some of the conversions will throw an error. Okay, just you can comment that line. So for example, let's say, so print of converting integer from yogi. Okay, so this will throw an error. We can't convert to yogi to integer, right? So for example, we can convert integer from string for these values. So for example, 10 is in string. So how we know it is in string? String means it is enclosed with quotation marks. Okay, this is the string. You can convert this 10 to integer, then it will come in integer 10. But we can't convert this, right? So this will throw an error. Let's run this once again. Run. So here asking 100, 100, 200, 100, 200. Now you can see after printing converting 10. Okay, so this is giving the error. So for them, you can comment this line. Just you can check what wherever it is causing the issue. Just comment. To comment this line, just to keep a hash in the starting of this line. This will not execute. This will not execute. Okay. So likewise, you can complete try to convert from one data type to another data type and check how these conversions are happening. Okay. Any doubts still now? Yeah, yeah, try to convert this and see the notes whatever till now we have, and we'll see if you have any doubts in the next class, and in the next class we will start the operators. Yeah, thanks. Yeah, thanks guys. Yeah, we'll meet in the next class. Yeah, thank you. Yeah, yeah, thank you.